Hi there, and welcome to part 3 of our PICO-8 Boulder Dash series. In this episode we are going to implement a map so that the player can move around in the map. We are reworking the move player function, and we will eventually go and put a little scoreboard on top of the screen. So let's get started. First thing we do is we actually put in a draw player function here and move this to our player class or player file, and here we go and say function draw player and put in the code we just deleted. Okay, so since everything in here is with player 1, we should probably call this player 1 too, just for clarity. Okay, next thing we do is we create a fresh file, and we use file 1 for that, and this is all the map stuff. And in here we put a function that is called Init Map, and we are not using this right now, and we are putting in a function called drawMap, which draws the map. And we put these two up here in the init. We say init map, and we say, and that is important to put the map before the draw player, because things are stacked on each other and the map is on the bottom, so drawn first, and then the player. If you do it the other way around, the player won't show because he's behind the map. So we put draw map here, and if we run this, there's no difference at all, but we have our framework done. So now we go and update our player function, and what we do is we change these coordinates from screen coordinates, which are 1 to 128, to map coordinates. So we only have 16 by 16 tiles on a screen. Every tile is 8 pixels in our case, and I will show you the tiles in a minute. And to do this, we can still leave this at 0, and we have tiles from 0 to 15. Player speed is still 8, but we are not really using this since we are right now only going a tile at a time. And in the draw player function, or in the update player function, we don't increase x by 8, which would be pixels, but we increase it by just 1 and decrease it by 1. Made a mistake here. And the same goes for the y coordinate. And since we are using screen coordinates, we are map tiles, we don't have the maximum at 120, but at 15, because we have tiles 0 to 15 on the screen. And the same is for the y coordinate, like this. And that should do the trick pretty much, but we have to change this, and we have to draw the player like this. So we have to multiply by 8 to really get him on the right spot on the screen. So let's try this. Line 20, tab 4. Oh, okay, I deleted something here. What did I kill? Should be a 1, right? Let's try this. As you can see, still works exactly the same. Only difference is we are now working with map tiles or map coordinates instead of screen coordinates. So that is one very important step. We are going to update the update player 1 function in a minute. Let me quickly show you a map. I already showed you the sprite editor, and I already drew up some map tiles. You can see these here. So here's a wall, here's some soil, here's the outer frame of the screen, here's a rock, key, another one of these tiles, use these for the background, a door, stuff like that. So you can use my tiles, you can just go and draw your own, doesn't matter. For now we are going to use, let me check, these tiles. So that is my map. I drew this map with my icons. So you just select which sprite you want and draw on the screen. And yeah, right, this is my starting point. So here's where our sprite starts. And what we have to do is we have to tell the program which tile the player can move on and which is kind of a wall or where a player can't move to. So this frame, for example, is a good place to not move. So what we do is we have to define in the sprite editor, we go back, and we have to say this is a place where the player can't move. And we do this by just checking this flag number 1. These are sprite flags. These are 8 kind of switches which you can switch on or off. And they don't do anything by itself. They do anything because we in the program do something with them. So we check if the sprite flag is on, and if the sprite flag is on for a sprite, then we now agree that the player can't move there. So we leave the soil without the flag, but the wall is again something we can't move to, so we give it another flag. And the rock we can also not move to, so we give this that flag too. Okay, so we have the wall, the frame, and the rock, which are solid and the player can move to, and we have the soil and the starting point, which the player can move to. So getting back to our map, we can see there is also the empty spot, which is good because there's just nothing. And we have these diamonds, which are sprite number, let me check, sprite number 58. And these are special in that the player can move on them, but they are also something the player has to collect and to get the score from. So we now agree on that sprite flag number 1, in this case, this is 0, this is 1, is used for stuff that the player can collect. In this case, it's a diamond. Okay, so these are the settings we need for our map. And now we can go in our draw map function and we can draw our map. And that works as follows. We say map, which draws the map on the screen, and we tell it which starting tile to use. So we want the top left corner, which is 0, 0, X and Y. We tell it where to draw the map, and right now we start with 0, 0, the top left corner of the screen up here. This is not a map coordinate, this is a screen coordinate. So this can be from 1 to 128. And we have to tell it how many tiles width and height to be drawn. So we want 16 by 16 so that all the screen is full. And that should draw the map. Let's check. And here we are. Our map fully drawn. You can see we can't scroll the map yet. And also we can move on spots where we shouldn't be able to move, which is not good. So let's fix that and make the player only move in spots where the where we actually can move. And that is where no sprite flag is set or where a diamond is. Okay. So in our init map function, we define some variables and we say a wall is sprite flag number 0 and a diamond is sprite flag number 1. So this is just that we can write cleaner code and don't have to remember which number is which. And now we have to go and edit our move player function or our update player function. And let's go and write a new function because it's cleaner. And we will leave the old function in place for now. And we will call that XX for the old version. So this one is not called anymore. We are now calling this one from our loop, which is here. We have a little change in our code in that we now check if a player can move to a specific place on the map before we move the player. So we have new x, which is player 1.x, and we have new y, which is player 1.y for now. So this is the current position of the player. And what we do now is, instead of moving the player or adding to the x coordinate like we did here, we are first going to add to the new x and new y. So the player x and player y are not tinkered with right now. And we only add to these two, then check if this position, the new x and new y position we have then, is actually a position where we can go to. And if we can go to that position, we move the player, and if we can't, we don't move the player. It's pretty simple. So if button press, and let's start with the left, then we want new x minus 1, minus equals 1. So we subtract 1 from the new x coordinate, not from the player 1.x, just from this. Same goes for the other direction. So let's just copy this. 1, 2, 3. And here it's not left, but it's Shift R for right. And if that is, we increase. And that is Shift U for up. And if that is, we decrease Y. And else we increase Y, which we do by Shift down. So now, after checking the button presses, we have tinkered with the x and y coordinates, or new x and y. If a button was pressed, if nothing happens, nothing is going to happen. And now we have to make a function which tells us if a player can move to a specific spot or not. So what we want to do is we want to check if the player can move to the new x and new y position. And to do this, we have to check if that spot on the map the player is trying to move to is a tile he can move on. So for that, we have to do a new function in our map section of stuff. And we call this can move to, and this has an x and a y coordinate. We have to get the tile at the map coordinate position. So we say the tile we can get with mget, and that gives us the tile at that specific position, so the sprite number of that tile. And we want the tile at x and y. And then we want to check, we want to get the flag of that tile that we can do with fget, flag get of the tile we just got, and we compare this with the 0, which is a wall. So we check if the wall flag number 0 is set on this tile. This is what fget does. If flag is true, so if this is a wall tile, then return false. So we can't move there, false. And that should do the trick. So we call the function, can we move to this new x and new y coordinate? We get the tile at the map position where we want to move to. We check if the flag, the wall flag, is set for that specific tile we just got. And that returns true or false. And if this is a wall, if this flag is true, then return false, because then we can't move there. Seems pretty easy. You could shorten this code a little, but for readability we will leave it like that. But we have to put an end here, I think. Okay, so next we have to put this in function here, and we use this can move new x and new y, and we say if can move to then, and I guess we forgot one then here, then we want to put the player to that position. Okay, I mistyped that here, so this has to be player 1 and not player 1 with the underscore. Hope that is correct in all the other places. Let's try this again. Yeah. And here we ran into a problem because we did put our player sprite in a spot where he can't move, so he doesn't have a way to go left or right or up and down. So we have to place our starting point of the sprite in a different position. Let's do this. So we're not starting at 0, 0, but we are starting at map position 1, 1, which is here. And you can see the coordinates down here. And this is where we want to, this is where we want to start. So let's try again. And that works, but we can still not move. Same here. Okay, we have the same error here. And you might have been screaming at the screen. Thank you. And we still can't move. Okay. We should probably return true if we actually can go there. And now it works. And we can't go onto the rocks, and we can't go onto the border. Nice. We can go to the diamonds, but we can't yet collect them. Nice. So now we have a map we can move around, and we have tiles that we can move to, and we are pretty much constrained to our map here. We can move off the map again. That's interesting. So let's fix that quickly. And to do this, we go to our player function, and now instead of just adding the new x, we go and use something that is called the mid function. And the mid function does the following. It checks if a given value, in this case new x, is in a specific range, which would be from 0 to the width of the map in the x case. And the map will be 127 tiles, not pixels, wide. So we check that. And if new x is bigger than 127, so if the player goes over the 127th map tile, it returns 127. And if the player goes below the 0 map tile, it returns 0. So it pretty much does the range check for us. And we can do the same here. And again, we have tile 0, but we have this, and we have a map height of 63 instead of 127, because the map can be 127 by 63 or 64 really, and 128 tiles wide and high. So let's check again. And that works. And you might wonder why we can still go over the map to the other screen or leave the map, that is because we can't see the complete map. We could, for now, just put a 15 here, and then we should at least be constrained to the x-axis. And you can see now we can't move past the screen. But since we want to do scrolling of the map, we have to do the constraint on the complete map, and that is 127. Okay, so now we have a player that moves around, that can only go where he is supposed to go, and we can't leave the map. So what we could do next would be to add the scoreboard on top of the map. And for that we have to put the map one notch down. So we are using sprites. I'll show you that. We are using sprites on a different sprite sheet for the score numbers, because I don't want the standard text. I want some Boulder dashy numbers here. And we need a function that converts a standard number to these sprites. And we will put these numbers on top of the screen. So let's check that out. And for that we go into our code editor, and the first thing we do is that we do a function, and I call this function draw as sprite, and it takes a value from a variable like score or number of diamonds, and it shows this at a specific x and y coordinate. We need a, since we are putting sprites on the screen which are 8 pixels wide, we need a start x coordinate, which is the x coordinate we are giving here. And then we are increasing this start x coordinate by 8 pixels when we put more sprites on the screen for the numbers. And we have a variable called numString, and that uses the toString function from Lua to convert our number value to a string, which we then go and chop up into the different numbers, and then use these numbers and match them with the sprites. So what we do now is we say for I numString. This is the hash sign, and that says the length of the numString. So for every character in this numString, so if you have a 100, you have a 1, a 0, a 0. This is 3 characters, so this runs 3 times because numString is 3 long. Do, and what we want to do is to get a character. So this character, we call this, is there's the auth function, which returns the character on position I, which is the position 0 in this case, and then goes further. So we get all the characters from 100. We start with 1, 0, 0. And we do put the sprite for that number on the screen, which is this character, which is this one, plus 16 at start x and y. We use the y from here and the start x from here. And then we increase start x so that the next number sprite will be shown on the next position. I guess this has some explanation to do. So we are drawing a sprite here, and a sprite is just a little block of graphics which we have right here. And you can see these sprites are all next to each other. So we have 64, 65, 66, 67. That has a reason, and that is because in ASCII all the numbers are also next to each other. So what I do here with this character is I just add 16 to the sprite numbers. So in ASCII, 0 is 64 minus 16, which would be 48, and the 1 is 49, and the 2 is 50, and so on. So this is a pretty easy way to automatically replace a number with a sprite. And if we use this, let's quickly check if this really works, and we go and put this in our draw function for now. And we say our value is 100 and we want this at 0, 0. Let's run this. There's a syntax error near do. Okay. We have at least to put a starting value here. So strings start with 0, not with 1, not with 0. That's good to know. And as you can see, there's 100. And it's drawn on the screen perfectly. So before we can put any values on the screen, we should probably check which values we need, and we will do variables for that. We have a level number of diamonds. We have a level minimum number of diamonds, which we need to clear the level. So the first number is the number of diamonds we have collected. The second number is we need to collect to finish the level or open the door. Then we have a level timer, which is, let's call this 180 seconds. And we need 20, and we have 0 right now. And we have a level, which we are on now, which is, let's call this level 1. And we have a player 1 score, which is 0 when we start. Okay, so now let's go and draw these on the screen, and we start with the level num diamonds, the number of levels already collected, and we put this at 0, 0. And then we draw the level min diamonds, the number of diamonds we need to finish this level, and we draw this at, let's say, 32, which is the screen coordinate, not the map coordinate. And we go and put the level timer here, which will decrease at 64, and we will put the player score, player 1 score at, say, 104. Okay, let's see. Yeah, there are our values. Feels like there's a value missing. Let's check. Okay, this should be level timer, not level. Now we are good. Okay. So still we don't want to have the numbers over the level or over the map. So we have to put the map a little down, and for that we go into the draw map function, which we have here. And we tell the map function where to draw the map. And these are the tiles which should be drawn. This is how wide and how high. And this is where on the screen. So we go here and we say we want to draw this at pixel number 8, because 0 to 7 are the pixels where the score is displayed in height. That should do the trick. Yeah. And here we go. Nice, but you can already see the problem here. Now our player starts here, and something with the map doesn't seem to work quite right. So we have to add 8 to all our functions. So let's define something called map offset, which is 8 pixels. Call this map offset x, no, y. So we can first delete our old update player function, because that is obsolete now. And here we have it, and that is indeed plus map offset y. Should at least put the player on the right spot. Yeah. And that is all that was needed. So now everything seems to be working perfectly. Okay, That looks like Boulder Dash already, a little at least, minus the Rockford and plus our Indiana Jones-like character. Yeah, I guess this concludes this episode. We have a scoreboard on top, we have a map, we have a player moving around on the map, only going where he can. And next up would be to scroll the map and to let him collect the diamonds and maybe even let him drop the rocks. So let's do this in the next episode. Until then, bye-bye.
Thank you for watching Retro is the New Black. If you are new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.